from this point, at this point you were given a polynomial, some sort of cubic, and I've told you what to divide the damn thing by, or I've told you what to substitute the letter x with. Well, now you're sort of left without the training wheels, and basically I just tell you something, and I tell you this cubic equation, and I tell you, all right, how am I going to go and factorize this? So, we have a little system to work with. The first part of the system is to find a number, I'm just calling a number A, whatever that might be, that divides into the final constant of, and solve, or final constant, I should get rid of that superfluous of there, to the final constant, and solve P of A. So the final constant, what I mean is this, friend. That is a constant. So a constant means it's just a number that ain't got no x. It hasn't got an x or a variable of some kind. So whichever value of a you get that results in a 0 answer, then we divide the polynomial by that number, or by x minus that number, then factorize the answer as possible. So I've got this friend here, so polynomial is equal to x cubed plus x squared minus x minus 1. I have no idea what any of the factors are, legitimately. I legitimately do not know, so I'm going to try and find numbers that fit inside 1. So, put your hand up, you can tell me what's a number that divides evenly into 1. 1. Or, there's one other. Negative 1. So, I'm going to substitute x equals 1. And the reason is, what I'm trying to aim for is I'm trying to aim for an answer of 0. Put your hand up if you remember why. Am I aiming for an answer of 0? What happens when I substitute 1, Mr. Schwab?
Which one?
Both, simultaneously. Yeah, so that would be a factor. So if I get an answer of equal to 0, I'll be able to get a factor. So we're going to go 1 cubed plus 1 squared minus 1 minus 1. So we get 1 plus 1 minus 1 minus 1. 1 plus 1 is 2, take away 1 is 1, take away 1 is 0. So therefore, x minus 1 is a factor. So we've done step 1. So that's step 1. If we want to make everything all lovely and color-coded, I'm going to put a little blue mark next to 1, so I can change colors. Now, when I get a factor, I can now do a cubic division. Okay. So, we're going to do this old division. Now, of course, learning from the best, learning from Mr. Zarebski, I need to make sure that I get everything circled as I do some divisions. So x goes into x cubed, x squared times, and then we do the old multiplying out. And so x squared times by x is x cubed. X squared times by negative 1 is going to be equal to what? Minus x squared. Then we do a subtraction. X cubed take away x cubed will be 0. X squared minus x squared. What happens when I've got two minuses? Plus. So what will be the answer here? Boom. Bring that old minus on down. And then we'll do a division. X goes into 2x squared how many times? 2x. And then we go and do a multiplication. So 2x times x, 2x squared, 2x times negative 1. Boom, negative 2x. And then we do a subtraction once again. 2x squared minus 2x squared is going to be 0. Negative x minus 2x is going to be equal to what? Plus x. Because negative 1 minus 2 is going to be negative 1 plus 2. So x goes into x once. And then we do our big old multiplication. 1 times x is x. 1 times negative 1. 1. X take away, better get my colours right. X take away x is 0. Negative 1 minus 1 is also 0. So, hooray. Now, as a great check, since we determined that it was a factor, if you get a remainder other than 0, you've done it wrong. So that's another way you can double check to make sure you are correct. So far, our factorized form, so our factorized answer, so far looking like this. X minus 1, x squared plus 2x plus 1. Now, sometimes that lovely quadratic can't be factorized and it can just say it as is. You don't need to complete the square or anything. But is there two numbers that multiply together that get positive 1, add together to get positive 2? Put your 1 and 1. And of course, if I get x plus 1 and x plus 1, that would be the same as saying, how can I make that nice and simpler? Square, yeah. Boom. So as an additional fact, that means that this cubic has an x-intercept at 1, 0 and negative 1, 0. That's just a fun fact. We'll talk more about that later. Especially when we come to solving and things like that. With this last one here, we've got, so there's 40. So we could either have a 1, 2, not 3, 4, 5, 8, 10, 20, and 40. And the negative versions thereof. So you'll see here that we get this awful big negative 94 going on here because we substitute 1. So if you're thinking, all right, oh my God, do you have to go through every single one of these numbers to work it out? One of the quick ways to do is try to think about mathematically. All right, I need a number that when I cube it, it becomes huge, such that when this times it by 94, they should cancel each other out. So I'm going to give a couple of these a try. I probably will try, I'm going to try a 4. I don't know if this, I have no idea if this will work, but I'm going to try it anyway. I reckon it might be negative 4. So let's try this. A good question was raised there. Someone was wondering why I was doing 320, or I did 20 times 16. I noticed that was 19 times 16. 19 times 16 is quite hard to do off the top of your head, or alternatively with paper. But it is 1 off 20, and 2 times 16 is 32. So 20 times 16 will be 320, and then I subtract 16 from that. And that is a very quick way to be able to do mental maths without having to do everything by hand. So we've got to that stage, hooray. So I can now move this up. So that means x minus 4 is a factor. And of course, 2 minuses make that a plus. So we shall do this division-y nonsense. So then we get x plus 4. For the final thing here, we need to factorize that 10x squared, this one here. So we're going to find two numbers that multiply together to get negative 10. But remember, we've also got this 10x squared. So you might remember from a few topics ago, where we do the crisscross method. So to see whether or not two numbers can work. So if I've got 10, I might try 5 and 2. And then for 10 here, we can try negative 5 and positive 2. So if we did this, 5 times 5 is negative 25x. 2 times positive 2 is positive 4x. Positive 4 plus negative 25 is equal to negative 21. Perfect. So we've got our results here. And so the final step for solving is then we make everything's equal to 0. So it's either x plus 4 equals 0, or, oh, I might use a different color. So x plus 4 equals 0, or 5x plus 2 equals 0, or 2x minus 5 equals 0. So x is equal to negative 4, x is equal to negative 2/5, x is equal to 5/2. And there we go, and I'll scooch that up.